Good evening, and welcome to Kopernik Observatory. For those that don't know me, my name is Drew Desker. I'm the director here, and it's great to see a nice crowd here, especially even on a sort of a cloudy night. But it's also great to see some old friends, some people I haven't seen in a while, and as well as people that are here practically every week. We also want to welcome those watching on the live stream. It's great to have you join us this evening. And so I'm going to ask all the people here at Kopernik, you're going to have to wave to the people on the live stream. So, hello, there we go.
Hi.
An active crowd. Anyway, it's great again to have you join us. By show of hands, who's here for the first time?
Hi.
Wow. Okay. Oh, great. A couple of people. Who here are members? Oh, wow, excellent. I didn't make very much money today. No, that's a good thing, really. A Kopernik membership is actually a pretty valuable piece of paper. Oh, sorry, thank you. All right. We belong to the Association of Science and Technology Centers. And so a Kopernik membership not only gets you into any Friday night that we have here, but also gets you into over 350 other science centers. So if you like this kind of place, you could go to Roberson, you could go to the Ithaca Museum, Ithaca Science Center, the Museum of Science and Technology up in Syracuse, the Intrepid Museum down in New York City, or the Franklin Institute down in Philly. And you get in for free, and you miss that big long line of people getting their tickets. So if you like this kind of place, consider getting a membership. We do this every Friday night from March to mid-December, and it's an opportunity for us to, sort of expand our knowledge about various topics. And it's not always astronomy, although tonight's happens to be about astronomy or astronomical topics. And but it's an opportunity to sort of plant some seeds. The other thing that Kopernik does is we do a lot of school outreach. So we go to schools. Schools come to us. We also have a very extensive summer camp program, and as well as a program called Girl Power. And Girl Power is something we really try to promote more women in STEM careers. So what we end up doing is offer programs for girls that are currently in 3rd grade through 8th grade. We have one actually coming up called Rockets to the Sky, where girls, it'll be actually on Friday, November 11th, which is the school holiday, the Veterans Day. So girls will come in, they'll learn about rocketry, they'll build an air rocket and launch it and do some engineering adjustments, but also they'll build some Estes rockets and launch them from here. And we always do a subject matter, we bring a female subject matter expert in to talk about the kind of work that she does. So for this Rockets to the Sky, we actually have an aeronautical engineer who works down at the Kennedy Space Flight Center and talk about the work that she does. And I apologize for those that have heard this before, but I think it's really poignant in that whenever we have the female subject matter expert talk, we also give our students an opportunity to ask her questions. And a few years ago, we had an astrophysicist who works at the Goddard Space Flight Center talk about the work she does using satellites to look at carbon dioxide levels and how that affects global warming. And then our girls get to ask her questions. And one of our girls asked the question, how did you get interested in astrophysics? And her answer was, well, when I was in college, I was an English major. But my boyfriend, he was a physics major. We would go from observatory to observatory. I eventually dumped the boyfriend, but I kept the astronomy. And now she has her PhD in astrophysics and works at NASA. So you never know where a seed is going to get planted. And so that's really what Kopernik is all about, is planting seeds. The other thing I'll talk about a little bit is the live stream. Back in March of 2020, when COVID sort of basically shut us down, he said, okay, well, we'll just sort of stop our Friday night programs, for a couple of weeks until this thing blows over. And obviously, that didn't happen. And so about 2 months later, we decided, let's see if we can try to stay connected with the public. So we have a YouTube channel, and so we started bringing those speakers. We would have them zoom into here, and then we would then turn that back around and push it out on our YouTube channel. the first couple ones were pretty rough, but as we made, as we learned and made improvements, things got better and better. We had some pretty nice, actually observing sessions. Jeremy, our live stream observer, I'm gonna tilt the camera over here. Jeremy, I don't know if you can, here, I'll do that. There you go. All right. So Jeremy does a fantastic job doing some live stream observing. We've done Comet Neowise. We had the Saturn-Jupiter conjunction. Back in May of this year, there was a lunar eclipse that at one point we had over 25,000 people on our YouTube channel. And and now we have almost 12,000 subscribers to our YouTube channel. So thank you. And if you're not already a subscriber, please do. One of the other nice things about our YouTube channel is that all of our programs that we do stay on our YouTube channel, so that if you're unable to make it up here or you miss the actual live stream, you can go back at any time and watch that. So anyway, we're very fortunate tonight to have, I was going to say how many times this has been. We're going to put a parking spot for you out here, I think. Anyway, Zoe Lerner Ponterio works at SPIF, and she'll tell you about SPIF in a moment, up at Cornell. And we're just very fortunate to have Zoe and all the information that she has access to bring to you. And she loves coming here, and we love having her. So at this point, I forgot one more thing. November 8th, another lunar eclipse is going to happen. But this one will start streaming at 2:30 a.m. So go to bed early and then wake up, or watch it in the morning, at your leisure. So Jeremy will be here, and I might even get up the gumption to come up and help as well. So anyway, back to Zoe. Zoe, thanks again for all the time and all the wonderful programs you bring, and we're looking forward to finding out what's in a name. So Zoe Lerner Ponterio.
Thank you very much, Drew. So now you've given me some homework. I'm going to go count how many times I've been here now. All right, so yes, I work at a place called SPIF at Cornell. Anybody here know what SPIF is? Heard of SPIF? Been to one of my talks before? No? Oh, great. Spacecraft Planetary Image Facility is what it stands for. And spacecraft go out there, they explore the solar system, and they explore planetary bodies. We consider that to be anything in the solar system that's not the sun. They take pictures, lots and lots of pictures. Missions like Voyager and Viking took tens of thousands of images, and they would print them all out, and SPIF was one of the facilities around the country that would have full printed sets of these images, as well as negatives. So we began as one of these facilities where you would physically go and rifle through the images to find what it was you needed. Now, of course, nowadays we don't do that. Everything is on an online server, but the number of images that spacecraft missions take has grown as well. The mission that finally killed the let's print everything out practice was Cassini, that went to Saturn. It was budgeted to do 50,000 images. The mission took 500,000 images. They said, no, we're not going to print everything out. Everything's digital, goes directly into servers, and so we have evolved, and we now keep archives of when we did print out images, but we also are an active research facility. So we will help researchers and students who want to take these images, analyze them, process them, make cool discoveries with them, and help them do that. But we are also a public facility, which means we provide outreach and educational support, K through 12 school visits and field trips. So we do both. I do both. And it's a very exciting job and suits me just fine. And so I'm going to keep coming to Kopernik as long as you keep inviting me. All right, so yeah, let's jump into tonight's talk, what's in a name. Now, I already know some people are in the comments section, but I kind of posed this as a challenge to see, did anyone manage to figure out what these names are? Specifically, what language this is. They are all from the same language. Tempting with the raw, but no. So I saw someone on the YouTube got very close, actually. Do we have any other people sending in their guesses? I know someone gave one in that was really close.
Yeah, just that first one so far. Nothing yet.
All right, so the comment on YouTube was, I believe, Polynesian or Hawaiian. You're very close. It is the language of Te Reo, which is the language spoken by the Maori people. So these are the people that are, indigenous to New Zealand. They are famous for their intricate dance ceremonies, their tattoos. I love how these dances have been incorporated into modern practices. Oftentimes, their teams will do these before sporting events to kind of like gear themselves up, ready. And they're just fascinating. And it's important to realize that Maori is specifically people of New Zealand. That your kids might be thinking Moana, and you're close, but Moana is a tale that takes place on the Polynesian Islands of the South Pacific. That is a different people than Maori, but closely related with cultural references. So I am going to start with a question that I actually get from kids a lot. We're going to start kind of close in, talking about this. What do we call things? What do we name things? And we're going to work our way out generally. So let's start with this. Kids ask me, why doesn't our moon have a name? It's a very valid question. The answer is it's the moon, the capital M. I don't know about you, but that's kind of disappointing. It doesn't feel very special. So this is a big subject, actually. English speakers sometimes will tell you its name is Luna. I've heard that used, but that's just moon in another language, so I'm not really sure that that really is any better. But it is where we get terms like lunar from. Just FYI, people that study the moon, planetary scientists that study the moon, we call them lunatics. They consent to this. They are fine with this. The people on Mars are Martians, and the people who study the moon are lunatics. Everyone's fine with this. It's all consensual naming. All right, so this is actually part of a way bigger problem. And usually if you've been to one of my talks, I typically just put up a lot of pretty pictures and talk. But tonight's talk is going to have more text on here than you would expect. And that's because we're talking about language, we're talking about words, and we're talking about stories and history. So what is the deal with the moon being called just the moon? Oh, yeah? Right.
Stars, but there was no other moon. That's the only moon we know about. So it's called Moon 1.
Exactly. So you are hitting right on there. So we're talking about before the time of Galileo, right? Moon was one of those things in the sky that we knew about since antiquity, right? As long as humans have been humans, and probably since before then, that was the moon. Now, it had all sorts of different names and languages, but it was capital M. It was a proper name of the object that was orbiting the Earth. So what happened with Galileo? Well, he discovered the moons of Jupiter, the 4 large satellites, the Galilean moons. But he didn't call them moons. I could find no record that he referred to them as moons, lowercase m. He actually proposed calling them Medicean stars after his patron. But in his notes, he typically just referred to them with Roman numerals for the order of their distances from Jupiter. And apparently a few times he even called them planets. So he is not to blame for this whole moon-moons confusion. So let's go forward. Kepler later coined the term satellite as a general name for something going around a planet. Sounds good, Kepler. Of course, then Sputnik came along, and we had to specify natural or artificial satellite. But I couldn't find where exactly the moment was that we started using lowercase m moon for natural satellites around non-Earth objects, but it's all over the place. Planetary scientists, we say moons all the time, and so it's there, whether we like it or not. But here's the question. If it's a proper noun, why does it only appear after the or Earth's? You don't say the Jupiter. We do say the Earth and the Sun. Now I have to take a step back and let you know something. I know that I am a science and math person, but I was raised by an English teacher. So I am also going to apply my exact same nitpicking of science and math to languages. I'm not responsible for what comes next. However you feel about it, you can either thank or blame her for this, because I decided to dive into this and say, what's the deal with the language? Houston, we have a problem. So what do we call the moon? The moon, big M, the moon, little m, Earth's moon, big M, Earth's moon, little m, our moon, big M, little m. What's the proper way? And then there's Earth, right? Earth, the Earth, our Earth, big E, little e. The sun has this problem. Same kind of thing. Which is the proper way to refer to the star we orbit? It goes even further. Solar system, right? What is it capitalized? Is it the? Is it our? And then you get out to this idea of universe. And so what we see here, of course, these are all objects where we at one point thought it was the only one in existence. Then we discovered there were others, and we just did not do a good job at coming up with a general term. Universe is the one that really might make your head scratch, because you're like, well, I mean, the universe is everything, right? But now you hear about multiverses. And it's not just like superheroes and science fiction. This is something that scientists actually entertain. This then will build the exact same question. Okay, is universe just a general term, lowercase u, for a collection of existence like this? Or is universe an uppercase U, referring specifically to our bubble of existence? And we're going to need to come up with names for others and come up with a general name for what they all are. Sometimes I've heard verse used for short. But yeah, this is the problem that happens. We didn't stop to really think a lot about the language we used. Well, to the rescue comes NASA. NASA has a style guide that they publish to tell us how we should look at all of this. So let's examine what it says. Okay, the moon. What does it have to say about the moon? So I'm taking quotes from the style guide. Capitalize moon when referring to Earth's moon. Otherwise, lowercase moon. So there. That's the proper way to refer to Earth's moon. But again, I'm not completely happy with this, because let's try this on for following the same grammar rules. Hi, I'm the Zoe. I'm very happy to be speaking tonight to all of you Zoes, and thanks to Kopernik Zoe Drew for that wonderful introduction. No? I mean, that's essentially what we're doing with the moon, right? All right. And also, this sentence becomes an absolute paradox, because the moon is Earth's moon. But I'm supposed to be always capitalizing when referring to Earth's, but then I would capitalize it twice, because I'm specific. All right, let's move on. Earth, what does it have to say about Earth? Capitalize the names of planets. Earth, Mars, Jupiter. Okay, yes. Earth, when used as the name of the planet, is not preceded by the. Okay, this is the whole you don't say the Jupiter thing. All right. When Earth is lowercase, it refers to soil or the ground, not the planet as a whole. All right, I'm on board with this one. This sounds good. Now, I do see people use our Earth, and as we now look for other planets around other stars, other Earths. But again, I'm going to say no, and I think NASA's on the right. They always use Earth-like or Earth-sized. Earth is a specific planet, this one. There are no others, unless we're in the multiverse. Okay, so this would be like saying, I am Zoe, and I'm happy to be speaking to you other Zoes tonight. No, NASA has said, no, we don't do this, and I'm on board. What about the sun? What does NASA style guide tell us? Don't use the in front, do use the in front of sun. Capitalize sun when referring to our sun, but not to other suns. We are right back with what we were having with the moon. Now, again, where do I think this is coming from? All right, I will own that the difference between saying moon with a lowercase m and natural satellite, I get it. Moon is shorter to say, it's shorter to write. And as long as we all kind of get around this weird grammatical rule, let's let it lie. But I'm going to draw the line at other suns, because we have a word for that. The stars. All right, there's already a nice, short, well-known word. Why do you say other suns? Now, I think this comes from the fact that when we first were starting out with this idea of could there be planets around other stars, we thought maybe every once in a while, maybe it's rare. And so we thought about other suns as like those rare stars that actually had planets around them. But now we know most stars have at least one planet around them, and so now that you say other suns, you're referring to almost every other star in the universe, most of which are stars very different from the sun. Our sun. I shouldn't have to say our sun, the sun. So this one, this seems really misleading. They're stars. They're stars. All right, the solar system one I think gets me the most, and that's because it just says do not capitalize the solar system. That's literally the only thing the guide says. And I'm like, okay, Sol. That's the Latin name for the sun. Solar system refers to this system. This is actually a quote from a NASA website. Other solar systems, called planetary systems, if they're called that, why don't you just say that? They're planetary systems. Solar system is the name of this place. It's a proper name. And so if you say other solar systems, then what's the name of ours? If you say other suns, what's the name of our star? Other moons, what's the name of our moon? Other Earths, what's the name of this planet? Thankfully, I don't work for NASA. And as long as I'm not producing NASA-sanctioned information, I can do what I want. And I'm going to choose to follow what seems to make the most sense grammatically. I will say the solar system, capital S's, and other planetary systems. I will say the sun, capital S, and other stars. If you'd like to specify whether or not the star is hosting some planets, you can call it a host star. And I will say the moon and other, okay, fine, moons. I'll give on that one. But how about this for an idea? What if we create like this worldwide contest and we go to every language where there's not a different word for those two things, and we have a contest, people get to suggest names for Earth's satellite. I mean, this could be a really amazing like public outreach thing, get people really excited and interested in astronomy. Or it could be a complete disaster because humans. But yeah, I really do wish that we had a name that was just for ours, just for our satellite. But sadly, we don't. But that was a whole long mess, a lot of words, and there will be fewer words for the rest of the talk. Bless you, Mom. All right, moving on to other things. Let's head out a little ways beyond just the Earth, the Moon, and the Sun. Voyager. Everyone knows Voyager, right?
Yes.
Yes, we went out and explored the outer solar system. There were two of them, Voyager 1 and Voyager 2. Now, both Voyager 1 and 2 went out and passed by Jupiter and then Saturn. Sent back amazing pictures, right? Saw these planets as we'd never seen them before. I really think that one of the big things that got me into this business was growing up just poring over those pictures. I was not alive to really comprehend. I don't remember the Jupiter and Saturn flybys. I just remember having those images as a kid. Now, Voyager 1, after passing by Saturn, took off out of the plane of the solar system, went on its merry way to head toward the edge of the solar system. But Voyager 2 kept going. And in 1986, it arrived at its next destination, the next unexplored planet, to find that. It's, to say the least, disappointing. The seventh planet was kind of a dud. Honestly, it gets worse, because this poor planet had its press conference canceled because that was the morning the Challenger shuttle exploded. So this is why probably no one remembers the Voyager 2 flyby of this planet. We all know it happened, but I don't remember much like happening, and that's because it looked like this and that happened. Now, one of the reasons we think it looked like that is because it's tipped on its side, right? That's what this planet is famous for being tipped on its side. And when we visited it in 1986, it was near its solstice. So you're the sun. Earth at solstice, right, is either tipping toward or away. And then you're getting either summer in the north, winter in the south, or, like we're heading to right now, winter in the north, summer in the south. But this planet is tipped completely on its side, which means solstice for it means one side is always in light and one side is always in dark. In this case, south hemisphere was always getting daylight and north hemisphere was always getting night. And apparently that makes the weather rather boring. And sure enough, 21 years later, that's a season on this planet, it turned so that now it was spinning and was getting day and night, and sure enough, well, storms. Interesting stuff happened. All right, so what to do about that? Well, first of all, looking back at that original image, I'm going to do that TV thing that they do, like enhance. Wait, I think I see something. Do we see something right there? Okay, what if I then handed this off to someone who could do an even better job? Thankfully, someone did without me even having to ask them. They took that image and teased out this. That right there, right? That's that right there. So there is a lot of stuff going on with this planet. We may have just been looking at it with the wrong kind of camera. All right, so let's go back a little bit, because this is a very interesting planet to talk about when it comes to naming things, because this is the first discovered planet. You might say, well, no, we knew of other planets before that. That's the problem. We knew about them forever, because you could see them with the naked eye. This is the first planet that actually has a discovery date, because you needed a telescope. And so that's where we're going to get into this gentleman, William Herschel. He was born in what is now Germany, but then he moved to London at age 19, and that was in 1757. He was a musician. He came there to find work as a musician, but guess what? He was also really interested in astronomy and started to get really caught up in that. And this started to remind me of another story of a certain someone that I actually know, and that is Adam Steltzner, aka Space Elvis. We call him that, because his backstory is very interesting. He too was a musician. He was in a rock band, and was just doing that, and suddenly got interested in the night sky and took an astronomy course at the community college, and fast forward, he's the one who led the team developing the sky crane that we now use to land rovers on Mars. But I'm getting off topic. Okay, back to this also musician turned astronomer. All right, well, he got so interested in astronomy that he actually started building his own telescopes to make observations. And so we have this picture of him out on an observing night looking through that. And on one very specific night, March 13th, 1781. Wait, hold on. Zoom and enhance. Who is this woman sitting here with a look on her face that I feel speaks straight into my soul? I think I know that expression. That is Caroline Herschel, William's sister, who would take notes while he observed. Good for you, Caroline. You don't look too excited about it, but I'm glad you did it. All right, so yes, on March 13th, 1781, he found something in the sky that was not in any charts. He at first thought it was a comet, but he continued to watch it night after night and finally convinced himself that nope, it was a brand new planet. What to call it? We'd never, as a human race, named a planet before. Not a new one. So he decided a great name would be Georgium Sidus, otherwise known as George's star. So he wanted to call it George. Why? Because His monarch was King George III. Yes, we almost had Planet George. Thankfully, after discussing things with other astronomers, he decided, okay, maybe we should keep with the whole mythology thing. All right, so they decided, all right, let's keep with that theme and go for it. Sounds good. And we got this name, the mythological reference being the father of Saturn and the grandfather of Jupiter. That sounds appropriate. Hold on, though. Who are we talking about? Because this is Caelus. Caelus is the Roman god of the sky, father of Saturn and grandfather of Jupiter. This is Uranos, Greek god of the sky, father of Kronos and grandfather of Zeus. So which one is it? Well, it turns out that the name we know is a Latin version of the Greek name, not the actual Roman name. I'm not exactly sure how this happened, but in looking back at a lot of things, there are a lot of confusions between the Roman and Greek gods. There's some that are very clear, like Jupiter and Zeus, but ones like this, I see them kind of back and forth. So the question then remains, I've not said its name yet. How do you say it? Well, I tried to dig. Now, the first level of digging was to find out that it actually was a Greek word, a Greek name, not Latin like all the other planets. And, as I said earlier, that would be pronounced Uranos in Greek. Okay, but we are used to saying it the Latin way. We're used to starting it with a ur, and either saying Uranus or Uranus. Which one in Latin would be correct seems to still be debated, though most people lean toward the Uranus pronunciation as being the Latinized version. Personally, though, I would like to see this brought together, so I have my own little solution that I use. I say, okay, I like this oo at the start. This oo is nice because it gets rid of a lot of the jokes that happen. Just ooh is a pretty sound. I want to acknowledge the ra, right? We're used to that ra. It's not a, it's a. That seems to be true in both languages. Neither one of these languages is in a. And then what to do? Well, it's nos, but it's a u, so just schwa it. That's what we call it in linguistics. Just make it a nondescript vowel at the end and call it a day. So I say Uranus or Uranus. That's my favorite. Uranus, which sounds so cool. All right, so why does this matter? Again, names matter because, honestly, we need to stop this, okay? It's fine to enjoy the joke once in middle school, but it's not even using the appropriate pronunciation. And honestly, you know, if this planet were a person, this would be just decades of bullying. And we teach our kids not to bully, right? It's not right to make fun of somebody's name, especially if you're purposefully saying it wrong so that you can make a joke. Did you have a question?
You mean the your anus joke?
That's the exact one. Right? That's the joke. But now I want every single one of you to imagine that that is you. And that is your name that someone is saying wrong and the whole room is laughing. How would you feel? Now we can say, well, it's not a person, it's a planet, it's not alive, but it's talking about the behavior. It's condoning that kind of behavior. It's saying it's okay to say a name wrong and make a joke about it. Again, have a fun time of it like the first time you hear it when you're young, but then really adults, because of course we just announced that we are finally going to send a flagship mission to this planet, to Uranus. And honestly, I could not stand the next month of news cycles after this announcement because NASA plans to probe Uranus. Deep probe Uranus. There's something going down there. NASA wants to probe Uranus in search of gas. NASA wants to probe deeper into Uranus than ever before. All right, we need to get it out of our system. First of all, that's not the way to say its name. Second of all, really, when was the last time you heard a spacecraft mission referred to as a probe? You're just like, wait, you're forcibly bringing that word up because you want to make a joke. You could call it a spacecraft. You can call it a mission. No, you're choosing probe because you want to be able to say this. And sometimes NASA does not make the best decisions because they then said, hey, everybody, what should we call it? You're asking the public to come up with a name for a probe going to Uranus. And I can say it went about as well as you can imagine. Now, I will fully admit to reading some of this list and having a good laugh on it because I appreciated some of the ones that were on the more creative side. I am not sharing any of them here tonight. Some of them are not PG, so if you want to go look at them, have a fun. Yes, it was a nice joke, but I had the moment and then I moved past it. Okay, so what should we call it? Well, I read some of the more serious suggestions, and there was one that really caught my eye that I'd really be on board with. Yeah, her. Caroline, because guess what? She wasn't just his sister who sat there and took notes. She was an astronomer, and she actually discovered several comets and the first 2 moons that were discovered of Uranus. No wonder she had that look on her face like, geez, William, when do I get a turn? All right, so I love this idea, like naming it after her. However, I will say that we should always be careful with names, and I think we need to be especially careful with naming things after people, because people aren't perfect, right? And there's been countless examples of naming things after people, only to then have some people dig up some very not nice things about those people. And yeah, there's an argument for that. And some people say, what, we can't name things after people ever again? I'm like, maybe. You don't have to. But yes, without having done much vetting, I like this idea. So what about this probe? Is it actually going to be a probe? Well, yes and no. You can see this is literally something someone threw together in CAD. All right, I know it's probably not going to look anything like this, but this is basically looking like the Cassini spacecraft. It's going to be something like that. And yes, they are planning on having an atmospheric probe similar to the Huygens probe that descended and landed on Titan, studying its atmosphere. Galileo released a probe that went into Jupiter's atmosphere. Yes, why not? Let's go and see what the atmospheric structure is. So here it is. This is literally what they have now, and this is probably all they have now because they just announced that they want to do it. They have some ideas. Your basic set of suites, lots of cameras, spectrometers to tell you what stuff is made of, magnetometers to see what weird things are going on with magnetic fields, study the structure of the atmosphere, and all of those things. Now, something I'd like to point out is down there at the bottom. Planned mission data volume return, 51.9 gigs. I think in today's day and age, that seems small, doesn't it? 52 gigs? I mean, like any thumb drive could fit that on it. This is a whole flagship mission. Why isn't it returning more data? Anyone have any ideas? It doesn't exist yet. It will likely be there for 10 years, abouts. So why only 52 gigs of data over 10 years? It's bandwidth, the distance. Intensity of radio, like any light, goes down with distance squared. Move twice as far away, your signal drops by a factor of 4. To give you an idea, Voyager 2 is currently 19 billion miles away, give or take. It puts out its transmission at 20 watts. By the time that gets received here on Earth, it has weakened to a billionth of a trillionth of a watt. That's 0.11 zeros before that 1. Now, granted, this is going to be 10 times closer than that. Let's square that. It'll be 100 times stronger. But that's still 0.9 zeros followed by a 1. So, yeah, this is going to be a bit of a trickle compared to what we're used to with the Mars gush coming down every day. But, yeah, that's another reason you want it to be there for a very long time. You'll need to get a lot of data down over a very weak signal. But let's get back to this Roman, naming, because we did return to it, right? We found Neptune, named it after the Roman god of the sea, which was Poseidon in Greek. All right, Roman. We got to Pluto. We named it Pluto, the Roman god of the underworld. This one's like, people's like, oh, Hades in Greek. Well, yes and no, because Pluto came from Pluton, which was the god of the underworld in Greek. Hades was actually from older in ancient Greece, and over the time of Greece being an empire, it actually shifted. Hades became known as the name of the place, the underworld, and Pluton was the god that ruled there. Names change, right? They evolve over centuries, and so Pluto was not invented by the Romans. It actually was a name that came from a Greek name. Or maybe we won't go to Roman, because then we got this one, Pluto's largest moon. And this one's got an interesting naming story behind it. So it was discovered June 22nd in 1978. That's only 3 months after I was born. By a gentleman by the name of James Christie at the Naval Observatory. Now, he was poring through some pictures of Pluto, and he found some plates which were marked defective. And here he is pointing to one of those plates. This is how we used to take images with spacecraft, on glass plates. And they said, it's defective because, look at it, Pluto's smeared, that's defective. And he pored over these for a while and was like, I don't think it's a smear. I think it's a moon. And they continued to investigate, and sure enough, that is what it turned out to be. That bulge was happening periodically. So clearly, that was a moon. So what to call it, though? Well, James is like, hey, I discovered it. I should get to name it, right? What would I name it? What would I name it? He thought, Oz. That's a cool name, right? Not great, James. He admits that he didn't know anything about mythology. Forget it. Well, he's out for a drive one day with his wife. And all of a sudden he says, Charlene, what if I named it after you? Her nickname was Char, and he said, how about we call it Charon? What was with the on? He thought it sounded sciencey, like electron, proton, neutron, Charon. And of course she was like, oh, James, that'd be so sweet, and stuff. And then he realized after this, he's like, oh, I should not have promised my wife I would name a moon after her, because his colleagues had all settled on Persephone, which is the goddess who became the wife of Hades, then Pluton, then Pluto. And okay, that's a pretty darn good name. And he was really like, yeah, I don't think I'm going to beat that. Until he was sleeping one night, and just not sleeping actually, in bed, like awake, like, I'm going to let my wife down, oh my God. And then he's like, wait, is there some way I can make this make sense without it being named after her? And he got up and dug into a box, found his encyclopedia, went to sea, and looked up Charon. And of course you can imagine his shock when he found out that Charon was the ferryman in the Greek underworld, with the Roman version being really not much of a change, Charon. So you will hear people say this moon as many different versions. Charon, it's English speakers trying to say Greek. That's not, I won't try because I don't speak Greek. Charon is one I hear a lot. But if you're in the know, you can call it Charon, because you know that that's what it actually is called, and that's why it was named that. So he snuck in naming a moon after his wife. Pretty good one, James. But moving beyond Pluto, they decided let's get beyond these Eurocentric names. So we have the dwarf planets beyond Pluto, Haumea, which is named after the the Hawaiian goddess of fertility. And up here, this is an actual image, but this is an animation based on that. It really does look like that. It's kind of oblong. Oh, and it has 2 moons. Kind of weird. Then we have Makimaki, which is the Rapa Nui god of fertility. The Rapa Nui are the indigenous peoples of Easter Island. And then we have Sedna, named after the Inuit goddess of the sea. And Kwarar, which is named after the Tongva god of creation. The Tongva people are the Native Americans who inhabited the area of the Los Angeles Basin. So yeah, we've realized that there's more mythology in the world than Roman and Greek. And so yay, we're acknowledging that the rest of the world exists. But inevitably, as humans do, we still find ourselves stumbling into some controversy. And that came to a head with this object. Who can tell me what the name of this object is?
The original name was Ultima Thule, but they had a problem with it, so they changed it, and I forget it's something with a name.
Yes, so you're correct, but nobody in here else knew either name. Remember that point. All right, here was its first name, 11101113Y, and they nicknamed it 11. Now, at the time, that didn't seem very interesting, but I'm sure if this had happened today, the Stranger Things fans would be going nuts. But yeah, literally, it's a number, and they nicknamed it with a number. All right, then it got a new name, Potential Target 1, or PT1 for short. And that's because it was identified as an object that the New Horizons spacecraft might be able to fly by after it passed by Pluto. It was eventually selected to be that target. It then got a new name. It's a provisional designation, 2014, that's when it was discovered, MU69. All right, then, as New Horizons was about to fly by in January 2019, so 2018, they said, let's have a little public contest to see what we can name it. Let's put out some names. People will vote. It'll be fun. And they announced that the winner was Ultima Thule. And they admitted that was just a nicknaming, just for the public to have some fun, and all was great, and it sounded like a cool name. Thule was the northernmost land referenced by the Greeks. Who knows exactly where that was, but it was the northmost thing they knew of. Ultima Thule was a Latin term that kind of then went beyond that, so it was kind of like beyond the known. That sounds cool. It was also used by the Nazis as the mythical homeland of the Aryan race. Ooh. So close. Okay, so, and here's the problem. A Google search could have revealed this. So debate ensued. There were some that said, just pick another name, and there were others that were like, yeah, but the press, right? There's all these news articles. The flyby has happened. This is what everyone's calling it. Can't change it now. Which you're like, yeah, you can. You can change it. And some of the team members even took this a bit personally and were like, you're accusing us of naming it a bad name? And we're like, you just didn't vet it well enough. And a lot of people just pointed out that it's like, it can't be that hard to just find a name that has nothing to do with Nazis. That would be nice. And so, thankfully, that did happen. And the International Astronomical Union, the IAU, we'll talk more about them in a moment, named it Aerokoth. And this was its official name given November 2019, so later that year after the flyby and after all the press around it. It is a Powhatan name. That is the tribe that the person that we call Pocahontas, which was not her actual name, was a tribe from, and it means sky. It still has a totally different full name, 486958 Aerokoth is its official name now. So one thing that I found kind of interesting was if you go to the New Horizons team website on this object now, it does refer to it as Aerokoth, It makes no mention of Ultima Thule. It also says that they announced the name Arakoth and makes no mention of the IAU, and still refers to Arakoth as a nickname. I think there's still some hurt feelings. Well, it also got two new names, Wenu and Wiyo, which are the names for the bodies. Originally, they were calling this Ultima and Thule, so they're like, well, let's name them. I searched. I'm pretty sure these must be Native American terms, but I turned up empty finding out like where they got these names from and what they mean. So please, if you figure it out, let me know, because I am dying to know where these names came from. I couldn't find any reference. Well, what happens when we go beyond this area of space? This is the Kuiper Belt, beyond Pluto. Well, this is also the place where a lot of comets come from, particularly the kind of comets that tend to come back again and again within a human lifetime. So how do they get their names? Well, at first it seems pretty straightforward. If you discover a comet, you get it named after you. That's pretty simple, and this is following from the very first comet to be named after someone, Halley's Comet, also known as Comet 1P Halley, the 1 being for first one and P being for periodic, comes back again and again. And so thus was born the custom of naming comets after their discoverers. Now, of course, there's a very sad story of the fact that Halley had identified this comet, identified 3 previous comings that all had happened with this about 76-year period, varied a little bit. He did all the math. He worked out like where would Jupiter nudge it and all this stuff, and he made a prediction that it was going to come back in 1758. And unfortunately, he died in 1742 before he would get to know whether or not he was right. He was right. But nature decided to be dramatic. It didn't show up till December that year, so it was like all the astronomers waiting all year to see if Halley's Comet actually came back. And then finally, at the very end of the year, he was proven right. So then you'll have comets that are named something like Comet Shoemaker-Levy 9, or Comet SL9, also with official designation D/1993F2. This was the famous one that had broken into pieces that then subsequently crashed into Jupiter, creating what can only be described as craters in the clouds that did eventually like fill in and disappear. But I've been doing cratering with kids, and they're like, do gas giants get craters? And I was like, you know, kind of. Yeah, sure. Something crashes into you, it's going to do something. So Shoemaker was after Eugene and Carolyn Shoemaker, who discovered a lot of comets, as well as David Levy, the other discoverer. 9 because this was the 9th one that they found. They were comet hunters, very famous comet hunters. And there's a problem, though, with this, and that's names can get kind of long. And so this is a very famous comet that the Rosetta spacecraft orbited. It is Comet 67P Churyumov-Gerasimenko. And yes, you have to practice to say that. Churyumov-Gerasimenko, just roll it off the tongue. And oftentimes, therefore, we just call it 67P or 67CG. So while it might sound cool to get your name on a comet, if your name is really long and hard for English speakers to pronounce, it's probably going to get left off somehow. And you might remember this comet from last year, Neowise. Is there someone whose name is actually Neowise, all caps? No, there isn't. Neowise is based on a telescope, the Wide Field Infrared Surveyor Explorer, which was a space telescope. And this was in its extended mission program, so they called it Neowise. It was discovered by a telescope, analyzed by computers, identified, and then followed up with humans, and so they decided to give the credit to the spacecraft. And so this is also another naming convention. It might be named after a telescope or a spacecraft that actually makes the discovery. Do you remember Comet Ison? Also within the last, year? That one was really interesting. I looked it up. It was discovered by 2 people, Vitaly Nevsky and Artyom Novoshonik. but yet it's called Comet ISON, and that's the telescope they were using to discover it. Maybe they didn't want their names on it. I don't know. But even something as straightforward as comets get named after their discoverers doesn't always pan out. Let's keep going out. On to the stars, right? Stars have names. They're cool names, right? What's this star's name? Betelgeuse. Betelgeuse? 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 We'll go with Betelgeuse. Okay. Betelgeuse, right? That's its name. Right? I can move on now, right? Where did it come from? Okay, well, like a lot of the bright stars in our sky, its name is Arabic. And that's because when Europe was having its dark ages, the Arab world was just flourishing in science and math and all manner of things. And the star catalogs that they created then made their way to Europe and shockingly did not get like Europe taken over by European terms and continued to be used. And so all of these bright stars that we know in our sky, Aldebaran, Antares, these are all Arabic names. In this case, it is Yad al-Juzah, which means the hand of al-Juzah, and al-Juzah is what they called this constellation. And you might say, how do you get Betelgeuse from that? Well, you'd like to think that. It turned out that some English person in the 13th century made a boo-boo. And he mistranscribed this ya as a be. So Bedaljuice became Betelgeuse somehow. Thanks, mistake. All right, so that's its name, though, right? This is also its name. BD plus 7, 1055. What is this? All right, well, BD stands for, I'm going to try here, Bonner Durchmusterung. Anyone speak German? Okay, that sounded better than mine. I'll go with it. It translates as the Bonn Observatory Survey of Stars. So it's referring to a specific catalog of stars. The plus 7 is 7 degrees north declination. So this is something, if you're an amateur astronomer, you understand completely. If you take Earth's equator and you project it out into the sky, you get the celestial equator. And if you go 7 degrees north of that, you know that that's where the star is located. But you need 2 coordinate points, right? On Earth, you need a latitude and a longitude. Well, that's half of it. So is 1055 the right ascension? Not exactly. It means it's the 1055th star, starting at 0 hours right ascension and heading east. So literally someone just made this strip of sky at 7 degrees north declination and sat there counting stars from west to east and giving them whatever number they were at, which means this is only good for you if you're counting stars in that catalog. Now, it does tell you where the star happens in that catalog, but it's not useful if you're looking at a different catalog. And as you might have guessed, yes, that means every star catalog has its own name for this star. Here's another one. IRAS 05524 plus 0723 and 2MASS J0551028 plus 072455. IRAS and 2MASS are referring to different surveys. And yes, now we're getting a little more familiar. This plus 7 and some dots is that declination. And this is actually a right ascension. So these are lat-long coordinates. The only difference between them is the one with more digits is more precise. But again, depending on where you're looking at it, you're going to get different answers. Also, culturally, there's different ways of doing this. We can talk about where it is in the sky, as in what constellation is it in. This is how they did it in Chinese records. This is what they decided was the 4th star in the constellation Shen, and so they called it Shen 4. And actually, in Europe, they did this too. The Bayer catalog does this, and so it's the brightest star in Orion. It's Alpha Orionis. So these are all its names. Actually, if you look into this star, there are over 40 names for this star. Now, this can get a little confusing. And thankfully, remember the International Astronomical Union, the IAU, the people that said, we're going to call this thing Arrokoth and not Ultima Thule. Those people are there for reasons like this, to say, we need to come up with a universal naming convention. What are we all going to call the thing? They came up with one. They finally decided on a spelling. So I grew up with this being spelled lots of different ways. When they formed, they came together and said, okay, this is how we spell it. And they actually are looking into stars that don't have a name like this, that only have catalog designations, and trying to give them names that you or I would actually remember and understand. And also trying to, of course, do so in a way that's more culturally diverse, because they are the International Astronomical Union. They have astronomers from all over the world, and we want to see that reflected in these new star names. You might also have heard of the IAU. These are the people who said Pluto wasn't a planet anymore. We're not going to open that can of worms tonight, other than to say it is a planet. We just acknowledge there's more than one kind of planet. Okay, and a major planet is not the best thing you can be in the solar system. In fact, moons are cooler. Moving on, though, naming stars, this question comes up. Can you really have a star named after you? All right, we see these ads. Here's one, star registration, name a memorial star. Name a star, a gift that lasts a lifetime. This is the starnaming.com. And then we have this one, International Star Registry, 40th anniversary. This one actually scrolls through, showing you examples of people that have had stars named after them. It's everyone from like past presidents to Martin Luther King Jr. to Princess Diana. It's just all this like, wow, we've named all these stars after people. If you want to do it, that's fine. But all you're doing is paying money for a little certificate, because the IAU stresses they frequently receive requests from individuals who want to buy stars or name stars after other people. Some commercial enterprises purport to offer such services for a fee. However, such names have no formal or official validity whatsoever. The astronomers of the world get to decide what the astronomical objects are named. But if you know someone in your life that would really love that gift and it would touch them and make their hearts warm, buy it for them and don't mention any of this. It's fine. It's about making them happy. So coming back around to what I said before, what is in a name? I hope you've seen that, one, names matter, right? And maybe they might not matter the same way to everyone, and we need to listen to each other. And if someone says a name bothers them and it doesn't bother you, that doesn't mean that it doesn't matter. Other people feel different things and have had different experiences. We need to be sensitive to that. 2, names change, right? We've seen this, like, and this is everyday life. Like, what we call things changes all the time. It's okay to say, all right, we're going to call this something different. My name when I was born was not Zoe Lerner Ponterio. All right, for one thing, I changed my last name when I got married. No one freaked out, and generally no one has any trouble with it. It's fine, names change. And so, again, advice, if you're naming something, please just pop it into Google, dig 5 or 6 pages down, because someone's going to do that. And you better know what they're going to come up with. But yeah, I'll leave it at that. Questions?
Any questions in the audience?
Questions, discussion topics, anything?
I think
Yeah?
If you look at,
actually, hold on a second. We're just going to, so that the people on the live stream can hear as well.
Oh, okay.
Yeah, I mean, if you look at detail on places like the moon or other planets, you'll see that there's a ton of names for specific, objects or items or landscape on these things, and I mean, you didn't comment on that, but can you maybe just give us an overview of your opinion on how that works out?
On specific naming conventions, or?
Copernicus on the moon. And, all the planets have stuff
Right. They have those names, and I would say that's fine unless we were to find one that was particularly troubling, right? If we suddenly looked back and we said, wow, maybe we don't want something named after that person because of what we now know about them. I think it's okay to say, yeah, we're going to name it something different. We do that with lots of things. But barring anything like that, I see no reason to change them. But the point is, we are explorers. The whole thing, astronomy is always pushing to the unknown. We're always discovering new things, which means we always need new names for things. And so naming things moving forward, I think we just should think more broadly. And there's lots of examples of this. Even though Herschel didn't get to name it George, he did get away with naming the moons that his sister discovered after Shakespearean characters, so that at least was a nod to the fact that he was considered himself an Englishman. That's cool. I like that. We actually, I believe it's Charon. Yes, I will say Charon. The features on its surface are being named after science fiction writers. So we're coming up with creative things and different ways of looking at names. And so I don't think we're ever going to run out of things to name. And so I don't think there's a reason to reconsider names unless there's a problem. Exactly. Stars. Go at it. Yes.
Wait, we got a question here first.
Yeah.
Did you have a question?
Do you know why the planet is the one that's very elliptical? Like.
Oh, Haumea?
Yeah, that one.
Yeah, okay. We don't. Like I said, we only have that one fuzzy image of it. It's so far away that we basically know it's there, and we know how big it is, and we know it's shaped like that, and we know it has 2 moons. And it's probably made of the same stuff as Pluto, mostly rock and ice. That is literally I told you everything we know about that object. So how it got shaped that way, we still need to figure that out.
All right, you had a question?
How are the planets named after people?
Say it again.
How are the planets named after people?
How are the planets named after people?
Right. So the planets aren't named, they're not named after people. They're usually named after, think of it like characters in stories, right? And throughout, all human cultures, every culture had its name for the planets. Everyone noticed that there were 5 things in the sky that looked like stars but moved differently, and gave them all these names. And so we saw that opening slide where you had the Maori words. Now, Mercury through Saturn would have been, since the beginning, but their languages also came up with new names as new planets were discovered. So yeah, typically planets, like I said, we didn't name it George. We said, no, planets don't get named after real people. But as we discover thousands of planets, who knows?
Any other questions here? Oh, pardon me a second. I'm going to sneak by here.
The asteroid 48695, that one, how did that numerical designation get where did that numerical designation come from?
I would love to know that. The first one I assume was just like a catalog ticker, the 11 one. Where the second one came from, again, I actually tried to find where it came from and I couldn't find anything that explained it, but I'm assuming they just moved it to another catalog and that's just the number I got there. Again, I encourage you, go dig. Tell me what you find.
Just sort of now serving 487.
Yeah, exactly.
Kind of thing.
Probably something like that.
Any other questions here? I will say, I have one comment, is that, when we talk about the various planets, we've got actually, for those of you who drove up, did you happen to notice the planet signs on the road?
Yeah.
Well, they're actually to scale. So again, Kopernik, for those that are watching on the live stream, there's about a 2-mile road between when you first turn onto Underwood Road to when you finally actually get to Kopernik. And where Kopernik basically developed the heliocentric model of our solar system, we say, okay, well, the sun is at the entrance of Kopernik. Then about 130 feet away, there's a sign for Mercury. Another 130 feet away is Venus. And 1.8 miles away is Neptune. We didn't put Pluto there because
it moves.
It moves. But my argument is that, again, we can name anything we want to name the way we want to name it. But I think everyone is so upset about it that it's because it's named Pluto. If we called it Eldon, nobody would care. But because it has the same name as that cute little Disney character, everybody's all up in arms about it got demoted, if you will.
I hate that word.
Put two Pluto signs out, one for its closest and one for its
Oh,
farthest.
exactly.
Possibly. When I do a model of the solar system activity, I actually will have them do 3 positions for Pluto. Its closest, its farthest, and where it is now. You know, because it varies quite a bit.
Now, as a matter of interest, the Planet Walk in Ithaca,
Yes,
does it have a Pluto?
it does.
It does.
That's at the Science Center, actually.
Oh, okay. Well, there
I
you go.
don't actually know what position, though, it is. If it was the position when they erected the
original.
Yeah.
All right.
I'd have to look into that one. I
Okay.
should know that.
So that's another trip to make is up to Ithaca to check out the Planet Walk. And with your Kopernik membership, you get into the Ithaca Science
Right.
Center for free.
So you start at the Commons, this is the sun, you walk it. It's a full 1 to 5 billionth scale model, so they do distances and sizes correctly. And it's the largest exhibit in the world. I'm going to plug it right here because we added, do you know about this? Back in, I think, 2013, we made it the largest exhibit in the world because we added Alpha Centauri.
Ah, all right, very good.
Do you know where it was?
Uh,
Or is right now?
Syracuse?
No.
I have no idea.
Hawaii.
Well, there you go. To scale.
To scale, yes. And actually, there's plans to put a marker on the moon eventually for a particular exoplanet system,
Wow.
so that no one will ever be the largest exhibit.
Also, for what it's worth, the Vestal Historical Society are putting planet signs along the rail trail, and it's going to actually start over by the Entenmann's. That's where the sun will be, and Pluto, I think, will end up somewhere east of Lowe's or something like that. Yeah, exactly. So, do we?
We do.
We have a question. Hold on, I'm going to pass it over to Jeremy.
So, are there any documented cases of names being derived from other sciences?
Well, I think, okay, names from other science. Well, you could argue that naming things after science fiction writers is definitely dipping into the outside, naming moons after Shakespearean characters. So we certainly do have names that come from things that are not fields of science. I think that we've gotten pretty creative with that. And I mean, the original names from mythology, I mean, that's also not science-based, but yeah.
All right, very good. And jumping a little bit outside the topic, but how do you know how old or young a star or planet is?
Ooh, very good question. So, well, that's kind of 2 different things. Planets are generally going to be the same age as their host star. I'm using my own words here. Planetary systems typically just form all together. Planets kind of form from the leftover bits of what was forming the star. Aging a star is actually not that difficult because we've studied so many stars that we understand that they all go through a pretty exact life cycle that is determined mostly by their mass. And that's because nuclear fusion at the core is a very precise and regular process. So if we can figure out the mass of a star, if we can figure out what color it is, that tells us temperature, if we can figure out how bright it is, we can put all of those together to pinpoint where it is along its lifetime and therefore how old it is. And then any planets around it are simply assumed to almost certainly be about the same age as that star. And they all typically form together. We now have pictures of this happening in process, planets forming from dust clouds around stars. So we have evidence to back up this, this hypothesis that planets form around their stars at the same time.
All right, we have a question back here.
Do we know how all of our planets in our solar system were made, like how the moon was?
Ooh. So yes, though of course we're always discovering new ways to understand it better. We now are very certain that Earth's moon formed from a collision of Earth with another planet that was the size of Mars. That's why it's unusual that a planet the size of Earth has such a large moon. That didn't happen to the other inner planets. For a long time, we assumed that Jupiter and Saturn, gas giants, would start forming like a rocky planet, but then just kind of grow super big and start to then gather gas onto them. We now have had missions to Jupiter and Saturn that have shown that they actually don't seem to have solid cores. They have metal and rock at their core, but it's kind of in a suspension of liquid metallic hydrogen. So that said, maybe they don't form at all like a runaway terrestrial planet, a runaway rocky planet, and that they form in their own special way that's a little more like a star than it is a rocky planet. So we're still unraveling all of the different ways that you can make planets and moons. Some moons are captured asteroids. Others are like, there's a trade-off between like Saturn, moons become rings and rings become moons. There's a lot of things going on.
I have another question down here.
Was the thing that crashed into Earth start with a TH?
I think that, what's the name that they give it? Theia? It does have a name. I love that we named a planet that doesn't exist anymore. That's beautiful.
And we get the sound effects to go with it.
Yes.
I have a question a little more on the lines of the imaging of planets rather than just the naming. We have really striking images of now all of the planets. And two of the most evocative pictures of planets are actually of Earth. There's the Apollo 8, I think, Earthrise, and then there's the pale blue dot, Carl Sagan from Voyager 1. Why don't we have a ton of pictures of the Earth and our moon from various distances? I think that would go a long ways to garnering public interest and just making a lot of our planetary science accessible to people, flat earthers and otherwise, as well as giving perhaps an overview effect to people and get us to sort of respect that our planet is just a little spaceship Earth. But since every probe we send out could take pictures as it's leaving, and it wouldn't even have to transmit them very far, I think Lucy, which is currently in flight, did that this month, but that's the first time I've really heard of any other probe imaging Earth on its way out.
I absolutely 100% agree with you. And yes, they do take those pictures, and I have a whole talk on it. So I'm glad that you told me this because it means that my talk is needed. It's actually called Shooting the Moon, and it started out as like a history of photographing the moon. But it included like, okay, as you know, pictures that included the moon and the Earth. So I can tell you that the picture that Cassini took of the nighttime of Saturn, where that little blue dot between the rings is Earth, if you zoom in, you actually can resolve the Earth and the moon, and that is currently holds the record of the farthest image of Earth's moon is from Saturn. The pale blue dot, that's too far, you cannot make out the moon. But yes, actually probes regularly, now I'm saying probes, you got me saying probes, spacecraft regularly use Earth as gravity assist to either speed up or slow down. And so a lot of these missions, even if they're going to Venus or going to Jupiter, they do Earth flybys before heading out there. And so there actually are a wonderful wealth of pictures. One of my personal favorites was not taken by a spacecraft traveling through the solar system, but taken by a camera on a Mars orbiter that was so good that it was able from Mars to turn and make a beautiful picture of Earth and Moon, where you can actually make out details. This is the camera that can see things on Mars down to 1 foot per pixel. So there are a wealth of images that are taken of Earth and Moon together, and if I can find, I think I was recently recorded with that talk, but I don't know.
Yeah, your Shooting the Moon was part of our Astrofest.
Right.
So it should actually, so if you go to our website, our YouTube site, I'm sorry, I believe it was on Saturday.
Yeah.
Yeah. So the day 2 of Astrofest, her Shooting the Moon talk will be there, and I believe Jeremy has actually different chapters set up, so you can. Yeah, they're all great talks, but you can, if you want to go specifically to that one, you can go and look where it is and click right there and watch that talk. So.
I love it. You're like talking about this, and I'm like, yes, yes.
Great. Well, Zoe, thank you once again. Actually, I have to say, you have an extraordinary closet of astronomical apparel.
Yes.
So I don't know if you can see that, but so these are spacecraft. No.
This is it's spacecraft in a mandala pattern. This is my newest acquisition, and I have yet to actually stare and identify what all the spacecraft there are. I know several of them. There's a few I look at and I'm like, what is that supposed to be? But
So let me just,
for
those in
those-
the live stream, they can get a good look at it. So, so next time Zoe comes down, we'll be looking for a new entry to your.
definitely. And then of course I have to say and it has pockets, big
good.
pockets.
Where does she get them?
I get them from Svaha. It's an online clothing store, and they basically have clothing for whatever you want to geek out over, and a plethora of space-themed stuff, but other topics as well. I have actually a QR code on my backpack if afterward you want to come up and snap that to get at their site on your phone. So.
All right, so we always promote, looking at the night sky after a program, and tonight's forecast a couple days ago looked pretty good, but then today it wasn't looking good at all, but the forecast was wrong because Jupiter and Saturn are out. I can see the Milky Way, and we have a rule here that you cannot leave Kopernik until you look through a telescope. So give me your keys, and
If it's not a cloudy night.
but it is not a cloud. Well, there is clouds there, but Jupiter has been out, Saturn has been out, and so I'm also very glad to see you're in your Star Trek shirt, and I'm glad to see that it's not a red shirt. And for those for those Star Trek aficionados, they would get that joke. All right. Well, anyway, thank you once again, Zoe. It's great to have you down.
Thank you very much.
And so, if you'd like to go straight through the lobby, through the double doors on the opposite side, and then to the left. And we've got we'll have Saturn and Jupiter available there. And as you head home, please watch out for the deer. I tend to walk through. Thanks again.